Welcome back. Today's lecture and tutorial is about middleware in ASP.NET Core. So these are essential concepts, in order to learn further in security and identity that we are going to take. So you please visit these concepts first before embarking onto a real journey in building scalable and complex applications. So a middleware refers to the software components present in the HTTP request processing pipeline in the ASP.NET Core. Now, each component chooses whether to pass the request to the next component in the pipeline. Now, it can perform work before and after the next component in the pipeline, and request delegates are used to build the request pipelines. The request delegates handle each HTTP request. Okay, that's a lot of theory. So let's do something practically. So I'll open the Visual Studio. And let's build an application, create a project, file, new project, ASP.NET Core Web Application, and browse it to the correct directory, which is this YouTube channel, project for videos, test. So this one, and I'll select this folder and name this application. Yes, middleware demo. Okay, I could create a web application. Let's make it ASP.NET Core 2.2. Right, and I can make it as a web application or a web application with the model view controller or an empty application. So let's make it create an empty application. Let's see. Okay, so with this empty project, we still have this startup class, and we have this program.cs class. Okay, so remember, in an ASP.NET Core application, it always starts as a console application and then gets its required things from the program, program class. The main method gets this essential stuff to build, to host and build and run from the startup class, and then runs it as a web application. Okay, so we are not going to take those things, but here you can see the topic is middleware. So now this middleware is here. There's a comment on the startup class which says that this method gets configure method, which takes two parameters of type iApplication Builder app and iHosting environment. So this method gets called by the runtime and use this method to configure the HTTP request pipeline. Basically, what it says that you can build all your middlewares or write the user-defined built-in middlewares in this configure method. Okay, so here what we are going to do is, if you look back to the slideshow, and if you go to the next slide, and before the next slide comes in, now request delegates are configured using run map and use extension method. We will soon see what they do. So run adds a terminal middleware delegate to the application's request pipeline, and use adds a middleware delegate defined in the line to the application's request pipeline. And map is something which actually is each maps given a particular filter, and it is based on the matches of the given request path. And if the request path starts with the given path, the branch is executed. So the next one shows diagram. Now this diagram says that this is the request. You can say this is the pipeline which contains say 3 middlewares, and this is the request response pipeline. Now the request comes here and it is intercepted by the middleware 1, which is nothing but a software components, and it in essence this is a request delegate, and delegates are anonymous functions or anonymous methods. So there is a next parameter which sends this request onwards to the next middleware, and there is some logic in these 2 middlewares, and the logic is executed before it travels to the third middleware. Now third middleware also has some logic, let's say, and once these 3 middlewares are passed through, now that's is the turn for the response to be generated in the request response pipeline. So after the last of the middleware is traveled, it reverses the direction. So from middleware 3 it moves to middleware 2 and then to middleware 1 before the response is handed over. Now the request delegates forming the middlewares in the request pipeline are called one after the other, okay, as shown by these dark arrows. As can be seen on the response cycle, the passage through the middleware is reversed. Now this is the example of a very simple request delegate, which is not exactly a request pipeline, but that can handle all requests. So we will put this code in the Visual Studio application that we have just developed, we have just created. Okay, so let's get back to the Visual Studio middleware demo, and on this one you can see it's already there. It's in the startup class in the configure method. So for the time being, just ignore this one. Environment is development. You can see that app.run async context, asynchronous programming this is. So await context.response.write async hello world. Okay, so here what you will expect if you run this application, it's Control F5. So all that you can expect is to pass a response back, which is hello world. So yeah, you got your hello world. So this one is really not a full-fledged pipeline, but this will be demonstrating an important fact that it is a terminal middleware. You can say it's an extension method app.run. So this is, it terminates the pipeline actually after writing a response back. It's saying hello world. Now what we can do is we can build onto this, and if you go back to the slideshow here, when the next delegate in the pipeline is not called, this is called the short circuiting. Now going back to the code, this one, it says there is no next parameter. Okay, so here you can see there's no next parameter. But if you look into the chaining, the next slide, which says that chaining the multiple request delegates through use. So use is an extension method which actually ties one middleware or chains one middleware to the next in the pipeline with the next parameter. Now next parameter represents the next delegate in the pipeline. We can short circuit the pipeline by not calling the next. If you don't write this line, So, or call the next parameter, you can short circuit so that it gets returned from the middleware that breaks the chain. Okay, so now here you can see I can create just a little custom delegate or middleware. You can see so what I can do is app dot run. Instead of app dot run, here you can make it app dot use. Now I will keep this part commented out for the time being, and I'll explain, come back to it later. So app dot use async context, that is HTTP context, and then next. Okay, so this use extension method, you can see that what this use contains. If you just delete this and use, what it accepts as overloads is middleware. That is the one one overload is it accepts the middleware delegate, and it also can get HTTP context, which is this one, and then task. So that is the next. Okay, right. So I am placing two arguments on this anonymous delegate, and then what I wish to do is await context.response.write async hello from first middleware or middleware one, hello from middleware 1. Okay, and then just copy it over and change it to hello from middleware 2. Okay, so and then I have to write another line, await next dot invoke. Okay, let's see. First, before changing, getting to the next one, let's see what happens if you run like this. Okay, and then I will explain. So this one is showing only hello from middleware 1. Why it is showing just hello from middleware? Because it is getting short circuited, because I am not calling the next. All right, dot invoke. Now let's see. Now this time let's see the output. Yeah, so now here you'll see that you got hello from middleware 1, hello from middleware 2. So that means the next parameter is in action. So it doesn't get stopped, the response doesn't get returned, but it is passed to the next middleware, which is this one, middleware 2, and the result is returned back on the browser. Okay, so now when the next delegate in the pipeline is not called, it is called short circuiting. It's desirable sometimes to save unnecessary work. For example, static file middlewares can serve as a terminal middleware by sending the requested static files like HTML, CSS, JavaScript files, and short circuiting the rest of the pipeline, because there is a static file middleware, and the static file, once the static file middleware is called, then the response is a static file that is served to the browser. So in that case, we don't need to pass it on to the next in the line in the middleware, so it needs to be short-circuited. The order in which the middleware are added in the configuration method of the startup class defines the order of the invocation of the order of their invocation on requests, and order is reversed for the response. Okay, so we'll stop at that. Now, before we leave, here is a quick recap of what we have learned in this class. A middleware is a software component that occupies the HTTP request response pipeline. Each middleware can pass the request to the next middleware in the pipeline without doing any processing on the request. The middleware can also do some processing of the request before passing it to the next middleware in the pipeline. A middleware can also terminate the further processing of the request, in which case it will be termed as the middleware short-circuiting the request response pipeline, okay, and hand the response back. When a middleware terminates further processing, the cycle is reversed in that the request travels in the opposite order to get the final response. The order in which the middleware are executed is very important to get the desired response back. If a strict order is not followed, we may not get the desired response back. That's all.